Okay, in this video, we're going to go through some questions in 4E. Now, 4E is kind of like, it's called direct proportion. So what that means is you're talking about the gradient in terms of some sort of context. So basically, as one variable increases, the other variable also increases, or it could decrease depending on what happens. So when you think about speed of a car, usually that's measured in distance over time. So we go like 60 kilometers per hour. So that means for every hour, we're expected to travel 60 kilometers. If we were going 2 hours, it would be 120 kilometers and so forth. So that's just what it means by direct proportion. I'm going to do some questions in a second. So I'm going to do questions 3, 4, and 5, but I just thought it would be a good idea to talk about the key ideas. So you can see here we have an axis. So on this side here on the right, and it says gradient equals rate, and rate is just, well, how things change over time, or it can be some other constant variable, but you don't always have a change that is linear. So this is linear, but for this topic, we're talking about the change being linear. So it's directly proportional. As one thing changes, how does the other thing change? So remember that your gradient is the value of m. So if you had an equation, y equals mx, m being the coefficient of x is your gradient. All right, so let's look at the 3 questions we're going to do. So first of all, question 3, write down a rule linking the given variables. So first of all, I travel 600 kilometers in 12 hours. Use D for distance in kilometers and T for time in hours. So first of all, it's asking you, now we don't have a starting point. So when you think about your equation being y equals mx plus c, for all these questions, we don't have, or we have a starting point, but it's at 0. Okay, so we're going to say, all right, c is equal to 0. So we're only looking at equations in the form y equals mx. Okay, so we don't have to worry about what our starting point is. And you can have different starting points. So you can have maybe a tank of water being emptied. So let's say it was a 10,000 litre tank. Your value of C would be 10,000. But we don't need to do that for this one. We're just focusing on the gradient part now. So our y-intercept is just 0 for all of these. All right, question A. 600 kilometers in 12 hours. So if we've traveled 600 kilometers in 12 hours, we can do 600 divided by 12 will tell us how many kilometers we've traveled in 1 hour. So that's going to be 50 kilometers per hour. Okay, so does that make sense? So if we've traveled 600 kilometers in 12 hours, we've traveled 50 kilometers on average per hour. So your equation, it says use D for distance and T for time in hours. So your distance traveled is equal to 50 kilometers per hour. So your equation is D equals 50T. So if we were to travel for 2 hours, your distance traveled would be 50 times 2, which is 100. And you can always check your answer just by substituting this in. 50 times 12 is 600, so we know we're correct. Okay, let's have a look at question B. A calf grows 12 centimetres in 6 months. Use G for growth in height in centimetres and T for time in months. Okay, so 12 centimetres in 6 months. That means it's grown 2 centimetres per month. So that's basically your gradient. So the variables we're using are G for growth. So the growth of the calf is 2 centimetres per month, where T is time in months. All right, I'm just going to scroll so we've got a bit of space to write on. Whoops, don't want to scroll too far. Okay, question C. The cost of petrol is $100 for 80 litres. Okay, so $100 divided by 80 will tell us how much it is per litre. So that's going to be, gosh, my maths 1.2, whoops, that's a terrible one, 1.25 cents per litre. So your rule is going to be the cost is equal to 1.25 N. So N is the number of litres you've put in to your car. It's quite expensive considering that petrol at the moment is under $1 a litre. The profit is $10,000 for 500 tonnes. Use P for profit and T for the number of tonnes. So 10,000 divided by 500. Now you can easily just do this on your calculator, but a way of doing it by hand is you can just cancel out these zeros. So you're simplifying that to 100 divided by 5, which is 20. So we've got $20 per tonne. So your profit is going to be $20. Okay, so profit is one variable and T for the number of tonnes. Okay, so just working out your gradient and then putting it in an equation given the variables. Okay, let's move on to the next question. So I want to try to keep this close to 10 minutes, but it's not going to be. All right, question 4. Maybe we'll just do a few of these. Use the gradient to find the rate of change of distance over time for these graphs. Use the units given on the graph. Okay, so here we've got in 10 hours travelled 1,000 kilometres. So you can see that point there, 10, 1,000. So to work out the gradient is 1,000. So our rise, we've gone up 1,000 and our run is 10. So again, you can just cancel that out and it's going to be 100. So your rate of change is 100 kilometres per hour. Okay. The next one, we've got 35. Okay, so we've gone up 35 and across 5. So it's going to be 7. So we've got 7 centimetres per second. This one here, we've gone up 20 and across 8. So it's 20 divided by 8, which gives you 2.5. So our variables, we've got 2.5 centimetres per minute. And then the last one, we've gone up 98 across 2. So that's 49. So it's going to be 49 millimetres per minute. And I've just noticed on this last two I wrote per, and here I just use the slash. You can use either one. Okay, so we're just working out the rate. And it's the same as the gradient. Okay, so doing the rise over run. All right, last question. Well, I did that one quickly, so hopefully we can move through this one equally as quick. The trip computer for a car shows that the fuel economy for a trip is 8.5 litres per 100 kilometres. So the trip computer is just showing us the fuel economy, basically. So question A, how many litres would be used for 120 kilometres? Well, we can, I think, it is easier to work out what it is per kilometre and then multiply it by what we want. So we've got 100 kilometres, oops, just give me a sec, I did that around the wrong way. Sorry, 8.5 divided by 100 will give you 0.085. And that's, so it's 8.5 litres per 100, so it's 0.85 litres per 1 kilometre. So if we've got 120, that's going to be equal to 0.085 times 120. And I'm going to have to do that on my calculator, and I'll do that in a second because I might just do B, because I'm sure you can easily use a calculator. Same thing, but we've already worked out what it is per kilometre. So we're just multiplying that by 850. And then C is slightly different because it asks us how many kilometres could be travelled if the capacity of the car's petrol tank was 68 litres. So if we've got 68 litres, we want to divide it by how many litres we need per kilometre. So it's 0.085. And I did do this question earlier, and I know that is 800. So we can actually get 800 kilometres if we had 68 litres of petrol. Now, let me just quickly get my calculator so I can do those other two questions for you. Oh, by the way, my calculator is my phone. Great maths teacher here using my phone as the calculator. 0.085 times 120. So that's going to be 10.2. Okay, so we need 10.2 litres for 120. And then the other one, 0.085 times 850, and that's going to get us 72.25. So litres for, 850. And you can kind of compare B and C. 68 litres gets us 800. So that means for 850 kilometres, we do need something just maybe slightly higher than 68, which is what we have. Awesome. I'm so happy I finished that video close to 10 minutes as possible. It did go a bit over. But girls, please keep asking questions. All right. Thank you. Bye-bye.